Hello guys, what's up? Today I'm going to be demonstrating a Class A audio amplifier. So yeah, let's just get into it. This is the breadboard circuit here. Yeah, and just a second, let me just show you the circuit first. Yeah, on my PC here you can see this is the circuit, and it's basically a three-stage amplifier. So first here we have the BC547 BJT. Second stage is a BD139, and the third is a TIP 3055. So the first stage is basically the small signal amplifier. We're going to be getting the audio here from a aux port here on you can take it from your phone too, but here I'm shooting with my phone currently, so yeah, I'm just going to be taken from the speaker here. So basically this is going to be very low. This is going to be barely 100 millivolts peak to peak. So that's all. That's the point of amplifier. You need to amplify the signal, so boost it. So first we're going to be giving it here the 100 millivolt to 120 millivolt RMS audio inside, and yeah, this is the overall circuit. I won't go into the details, but the first stage is a small signal amplifier. So there's a voltage divider bias, there's a collector, emitter, resistor, and input capacitor. Definitely to block all the DC, we need this for AC coupling, so that only the AC passes through. And there is a bypass capacitor across the emitter resistor, and that's to improve the gain. And yeah, so we take the output from the collector. So this is a common emitter configuration, and another coupling capacitor of 10 microfarad to again block the DC, only allow AC to go through it. And the second stage, which is actually a buffer stage, and that's why I've chosen the BD139. It's a standard mid power BJT. The BC547 is a small signal BJT or low power BJT. This is a mid power, and this just acts as a buffer. So another voltage divider to set the forward bias the base emitter junction to switch on the BJT, and there's a small emitter resistor 240 ohms. And this is basically, this setup is called a common collector or a emitter follower. So basically whatever it gets at the base, sorry, one second, yeah, whatever it gets at the base, that is what is going to show up here at the emitter. So it's, you could say it's no gain, or as they call it, a buffer only. Yeah, that's why it's aptly called a buffer. There isn't going to be any gain in this stage. All the gain that we want is going to be in this first stage. So yeah, the second stage just acts as a buffer, and the main point you would say, why can't you directly use it from the BC547? The thing is that the BC547, it's very low power, so it can't give enough current to drive this third stage, which is the power stage. So that's why we need the buffer stage to give enough base current to the power stage. So that is the second. The third stage is the tip 3055 power BJT, and that's purely for supplying enough current, because there's going to be a lot of current in this stage. Here there's going to be barely any current. Here there's going to be again barely any, but somewhat more than this one. But this is also this is going to be having a lot of current flowing through it, so we can't use any normal BJT. So this is a power BJT. And same, there is this is actually correction. I actually found this out while I was doing the circuit. There shouldn't be a capacitor here actually. No coupling capacitor, because in the power BJT, if you can see, we don't have a voltage divider here. So if you block all the DC, the base emitter junction is never going to get forward biased, and your power BJT will never turn on, and you will basically never get an output. So you definitely need to remove this. I found this out the hard way while making the circuit. So yeah, let me just connect this right here. Correct. So this is the correct circuit. So the emitter follower, we take the output from the emitter, it goes to the base resistor. It's just for current limiting, 100 ohms. You can try and vary this if you want, but I found that 100 was pretty good. And yeah, and there's no collector resistor again, similar to this one. This is also in the emitter follower configuration, so no gain, just for power. So no collector resistor, collectors directly to VCC, and the emitter has a very low resistance purposely. And this, all the other resistors you can use 1 by 4 watt standard 0.25 watt resistors, but here this one needs to be a high wattage or power resistor. It needs to be at least 2 or 5 watts. I would say 5 watts is good. So I have used 5.7 ohm, and that is to set the base current. We need a high base current, so that's why we need a very low resistor here. so accordingly the power dissipated is going to be more, so use a power resistor. And since it's in the emitter follower configuration, we take the output from the emitter of the power BJT, and here this is again a coupling capacitor, but this time we need a very big coupling capacitor. And that's because the sound, as you know, the standard sound in the human hearing range is from 20 hertz to 20,000 hertz or 20 kilohertz or 22 kilohertz, yeah, whatever, between 20 to 22 kilohertz. So we need it to be a high pass filter, so allow frequencies above 20 hertz. So that's why we need a, just if you just put in the formula, the f is equal to 1 by 2 pi rc, the standard frequency formula, you, according to whatever your speaker is, and my speaker is a 8 ohm 10 watt speaker, so, and my VCC is 12 volts everywhere. So accordingly, if you just put it into the formula where the impedance R is going to be 8 ohms and 1 by 2 pi RC, and the frequency is, sorry, the frequency is 20 hertz, then you get around greater than 2000 microfarads. So 2200 is a good start. And yeah, you connect the speaker, and then the other part goes to ground. So basically, whatever DC component is there here across this, that is all gonna get blocked. Only the amplified RMS AC is gonna pass through and go through the speaker, and that's what we're gonna hear. So yeah, I hope you understood the circuit, and let's go to the demo now. It's basically here. So yeah, this is the small signal stage, that's the BC547 there, all the capacitors, that is the BD139 there, yeah, and the last is the tape 3055. And as you can see, the other two don't have any heat sinks because, as I said, there's not going to be a lot of current flowing through it, but this one definitely has, according to me, I measured it to the ammeter too, it's almost 700 to 800 milliamperes, which is close to 1 amp, and that's a very high current. So if you don't put a heat sink, I checked, the temperature goes almost to 110 degrees, and that's very dangerous. This power BJT is rated for max 150, so we definitely need a heatsink. So it's mounted on a heatsink to maybe limit it to 50 degrees. That's what I saw. That's a good one. And that is the power resistor I mentioned, 5.7 ohms, and the large coupling capacitor, 2200 microfarad, and that's the 8 ohm 10 watt speaker. And yeah, I'm giving the 12 volt VCC through my bench supply here, and the audio input as earlier through the speaker. So let me just play a sample audio here first. Yeah, so just playing a sample audio first. Let's switch on the VCC. So yeah, the circuit is on. Now we switch on the AC input. So now you can see, and there's also, I forgot to mention, there's a pot. It's my mistake, I forgot to show it in the circuit diagram, but yeah, there's a pot in the small signal stage just at the input here in series with this. Yeah, so a pot, one end goes to the audio input, the wiper, which is the middle, goes to the coupling capacitor, and the other end goes to ground. So you can get proper attenuation where the least resistance you're going to get the maximum input signal, and as you go towards ground it's going to get attenuated. So yeah, I forgot to show that, it's my bad. So let's play the music now and see how the output is. So I have started the music. You can see this is at, actually it's not even fully turned up. So now let me just turn it up. I won't speak so you can fully hear the music. So yeah, as you can see, this is very low. This is practically zero. Let me just make it zero. So you can see the music turned off. It's fully attenuated. So it's basically ground. And I'm going to max it. Yeah. So yeah, that was the demo, and you could see that despite going to almost the full volume, which is very loud here, you may not hear it through the camera, but it's very loud. So yeah, the whole point of the loudspeaker, the amplifier is working very well, as you can see. So yeah, that was the demo. I hope you liked it. Bye.